We have a process with different results at different temperatures, and we want to verify whether or not the temperatures have an effect on the process. So at these 4 different temperatures, we produce these amounts of plastic cups, and out of those amounts we have these numbers rejected. So for each temperature there's a different number produced and a different number rejected. We want to use the chi-squared test of goodness of fit to see if there is in fact an effect from temperature. We need values for observed and expected, and we're going to have these for all the different temperatures. So at temperature 1, we observe 138 cups accepted and 12 rejected. So this is like if we toss a coin 20 times, we observe, say, 13 heads and 7 tails. We had 150 cups, 12 were rejected, that means 138 were accepted. So we observe a number of accepted cups and a number of rejected cups. And we have those observations for all 4 temperatures. So here are our observations. You can see there are 8 of them. And our claim is that there is the same rejection rate at all temperatures. In other words, there is no effect of temperature on the process. And we're going to try to prove that null hypothesis, that there's no effect of temperature. So if there's no effect from temperature, then there's the same rejection rate at all the temperatures, and that rate is given by the sum of, well, one estimate for that rate is given by the sum of the rejected cups divided by the sum of the produced cups. And this is 43 divided by 545. And we will use this rate along with the total number of cups produced at each temperature to get our expected values. So here it is written out for temperature 1. At T1 we produced 150 cups, and so we expect to accept 150 times the difference between 1 and 43 over 545. So we expect to accept 138.17 cups, and then we expect to reject pretty much 150 minus this, or 150 times this rate. So 150 times 43 over 545 is 11.835. And we used our data to come up with these expected values, both from the rate that we calculated and this total here that we used, 150. And we'll just use those same rates but the different totals for the other temperatures. So 75 times 502 over 545 gives us 69. 75 times 43 over 545 gives us 5.9. And thereby we come up with expected values for the other temperatures. And now we have observed and expected values at each temperature for the accepted and rejected, and so we can compute chi-squared. It's just the differences between the observed and expected values squared divided by the expected values. So we'll have 8 of these. So here's the observed accepted, expected accepted at T1, observed rejected, expected rejected at T1, and so on for T2, T3, and T4. And we come up with a value of chi-squared equals 1.3623. Now, we need to see what the probability is for getting a chi-squared value bigger than this, and to do that, we need to figure out the degrees of freedom for this case. So degrees of freedom is n minus k. N is the number of observations, so we already saw that there are 8 observations, so there are the 8 observations, so n is equal to 8. And then we subtract from that the constraints, which is the number of times that we use our data to come up with our expected values. So let's count the number of times we used our data. Here's 1. We used it to come up with this rate. And here's another. We used the 150 to come up with the expected values at T1. So we used 150 here and here. And then we use 75 here. So we got 1, 2, and then we use 75, and then we use 120, and then we use 200. So that's 1, 2, 3, 4, 5. So 5 times we used our data whenever we were coming up with numbers to use for our expected values. So we get that the degrees of freedom is equal to 3. Now if we go to our chi-squared table, look on the line for 3 degrees of freedom, and go over to where we find chi-squared 1.36, that's going to give us a probability somewhere between 0.5 and 0.75. So this is saying that there's at least a 50% chance that these differences here between what we saw and what we expected are just caused by random chance. And so there's really no problem with our model. So we can accept the claim that temperature has no effect on our process.